So good morning students. So are you able to hear me?
Yes, ma'am.
Um, can you see the whiteboard?
Yes,
Yes,
ma'am.
ma'am.
Okay, today we'll start the first unit. So in the first unit you are going to start about the number system. So in the you have different number systems. So in that you are going to study about decimal number system, binary, octal and hexadecimal number system. So hope you all know that is you have prior idea about that. So anyway, we are going to brush up about this number system and the conversions. So first we'll see about the decimal number system. So decimal number will have a number. So decimal number will have a number from 0 to 9. So any digit from 0 to 9, it will have a decimal number. So the base is 10. So totally you have 10 digits in the decimal number system. So that only the base is 10. So your number will be having from 0 to 9. So for example, 7, 9, 3, 7, 6, anything like that is a decimal number system, decimal number. So your base you can write it as a in the lowest suffix. So this is a decimal number. So next number system is a binary number system. So binary number system, as you know, it has only two digits. So binary number system has two digits, that is only 0 and 1. So since it has only two digits, it has a base of 2. So any number which has 1, 0, 1, 1, 1, anything can be a binary number and you can write the base as 2. So this is a binary number and base is 2 because it has only two numbers, 0 and 1. So on the next number system is a octal octal number system. So octal number system can have 8 digits, that is from 0 to 7. So the base of octal number is 8. So any number, so between 0 to 7 can be a octal number. So you can write the base as 8. So this can be as a decimal number or can be a octal number. So it is always better to write the base in the suffix. So it is a octal number. So base of octal number is 8. So next number system is hexadecimal number system. So hexadecimal number system can have 16 values, that is from 0 to 9 it can have, and then next it can have A, B, C, D, E and then F. So A value is 10, B is 11, C is 12, D is 13, E is 14 and F is 14. So sorry, F is 15. So it can have value from 0 to 9 and A to F. So totally it can have 16 digits. So your base of hexadecimal is 16. So you have number system, decimal number system, base is 10. It can have a digit from 0 to 9. And the next number system is binary number system, base is 2. It can have numbers only 0 and 1. The next number system is octal number system. It can the base is 8. So it can have a number between 0 to 7. And the next number system is hexadecimal, base is 16. So it can have from 0 to 9 and A to F. So A value is 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So these are the number system you are going to use and you need to know the conversion among these number system. So first we will see the binary to decimal. So any number system to decimal number system we will see. So first we will going to see from binary to decimal number system. So for example, you have a number 1011 and this is a binary point 101. So for example, you have a binary number, you want to convert it to a decimal number. So any number system, you want to convert to a decimal number system means you have to multiply each digit with its base. So now here you are going to convert from binary to decimal. So you are going to multiply each digit by its base. So base of binary number is 2. So from the binary point, so right side you have a fraction part. So first the digit you have to multiply with 2 power minus 1, and the second is 2 power minus 2, and third will be 2 power minus 3. And from the binary point to left hand side you have to this you have to multiply with 2 power 0. This you have to multiply it with next will be 2 power 1, 2 power 2, 2 power 3, and goes on like this. So I will show how to convert binary to decimal. So take this. So this digit is 1. So 1 into its place value is 2 power minus 3. So because from the binary point, next will be 2 power minus 1, 2 power minus 2, and next will be 2 power minus 3. So 1 into 2 power minus 3. So 2 power minus 3 can be written as 1 by 2 cube. So value of that will be 0.125. So 0.125. And the next will be 0 into 2 power minus 2, whereas 0 anything multiplied by 0 will be 0. Then 1 into 2 power minus 1, so that is 1 by 2, value is 0.5. So the value is 0.5. Next is, so this is left hand side to the point. So 1 into 2 power 0. Anything power 0 is 1. So value is 1. And then 1 into 2 power 1. So 2 power 1 is 2. So 2 into 1 is 2. And the next is 0. 0 into 2 power 2. So 0. And the next one is 1 into 2 power 3. So 2 power 3 is 8. So add all this thing. So you get 11.625. So that is your decimal value. So is it clear? So are you able to understand? So binary to decimal, if you want to convert, so the base is 2. So you have to multiply each digit with its place value. So from the point, you have to multiply with 2 power minus 1, 2 power minus 2, 2 power minus 3 in the right side. And to the left side, you have to multiply it with 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on like that. You have to add, you get the decimal value. So for 1011.101 for binary number, your converted decimal value will be 11.625. Is it clear? So is it everybody clear with this? Binary to decimal? Anyone can reply, so that only I can continue with the next topic.
Yes, ma'am. Clear, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
next is octal to decimal. So similarly, the same procedure, instead of base 2, here you have to use the base 8. So that I will show it in the PDF. So here, can you see this PDF?
Yes, ma'am. Yes, ma'am.
So now you are going to convert octal to decimal. So here the number is 127.4. So you are going to multiply the same procedure, same binary to decimal, same procedure you are going to perform, but instead of base 2, you are going to use base 8 here. So 4 should be multiplied by 8 power minus 1, and 7 should be multiplied by 8 power 0, 2 should be multiplied by 8 power 1, and 1 should be multiplied by 8 power 2. So all this you add, you get the value of 87.5. That is the decimal value. So the same procedure, if you want to convert any number system to decimal, you have to multiply that digit with that place. So instead of that, you have to use the base number. So 2 power 0, 2 power 1, 2 power minus 1 for binary, and for octal you have to use 8 power. And next is hexadecimal number. So hexadecimal number is similar thing, that is here I have used a number B65F. So F value is 15. So I have multiplied by 15. So here I don't have any fractional part. So I have multiplied by 15 into 16 power 0. So here you have to, instead of F, we have to use 15. So because F value is 15. So 15 into 16 power 0, 5 into 16 power 1, 6 into 16 power 2, B value is 11. So 11 into 16 power 3. So add all this thing, you get the decimal value. So in order to convert one number system to decimal value, you have to multiply by its base with a place value. Is it clear? Is it clear, or you want me to work out and show you? Is it clear or not?
Clear, ma'am.
So next, we are going to convert from decimal to other number system. So you are going to convert decimal to binary, or decimal to octal, and decimal to hexadecimal. So first I will show you. So next I am going to show you how to convert decimal to binary. So take a number 41.6875. So this is a decimal number. You are going to convert this to a binary number. So here you have to take fractional part separately, do the conversion, and then integer part convertly and do the conversion. So take 41 first and convert it. So for 41 you have to convert means, so 41 you have to divide. So if you want to convert decimal to any number system, you have to divide by 2. That is base. So since the base of binary is 2, you have to divide by 2. So 2 2s are 4, and 2 1s are, sorry, 2 0, and 1 is remainder. Then 2 1s are 0 0, then 2 5 0, then 2 2s are 4, remainder 1, then 2 1s are 2, remainder 0. So you have to divide the 41 by 2 and write the remainder in the side. So you have to write in this direction. So you have to write in this direction. Then I will show how to convert the integer part, and in the end we will write both this. So the fractional part is 0.6875. So you have to convert this. So for that, for fractional part to convert to binary number, you have to multiply by its base. So base, since the base of binary is 2, you're going to multiply the fractional part alone with the 2. So 0.6875 into 2. So what is the value? So you get the value of 1.375. So you have to take this one. So in the next step, you have to take it as 0.375 and multiply by 2. You should not take 1.375 and multiply by 2. So you have to, even though you get a 1 here, you have to take, you have to remove that and you have to take 0.375 and multiply by 2. So 0.375 into 2 is 0.75.
0.740.
0.75. So you take the 0 then. Then in the next thing, 0.75 into 2. So you get the value of 1.5. So you take this value. So even though you have 1.5, in the next step, you have to take only 0.5. So 0.5 into 2, you get 1.0. So you have to stop here until after the point you get the 0 value. So in some case, it goes on like that and repeat the same value before it. So you have to stop that, you can approximate it. So you have to truncate and all. So that is next problem. So that is the different problem. You need no need to take here. So you have to take until you get 0 in the right hand side. So now after completing this, so you have to, so after completing this, you have to write as a decimal number. So already integer 41 you have divided and you have obtained the value. So you have to write this as, so from bottom to upwards you have to write. So 1, 0, 1, 0, 0, 1. So this is the uh, integer part, and the fractional part. So you have to write in this direction. So from top to bottom. So 1, 0, 1, 1. So this is the converted binary value. Is it clear? Is it clear for you? So for decimal to any number system, you have to separately find for fractional part and the integer part. So for 41, you have to divide this and you get the reminders value, and you have to write from the bottom to the top. And for fractional part, you have to multiply by base. So you have to take only the right hand side part, and that too you have to write from top to bottom. Is it clear? So, and while multiplying, take careful that while taking, that is, if you get the value of 1.37 or 1 point something also, in the next step, you have to take only 0.375 and multiply. You should not take 1.375 and multiply. You have to take only 0.375 and multiply, and you write from top to bottom. Is it clear? For decimal to binary number system conversion, you have to divide this by base for integer part, and for fractional part, you have to multiply by its base. Is it clear? So next, is it clear or not? I want
Yes,
acknowledgement
Yes,
from
ma'am.
ma'am.
Yes,
anyone.
ma'am.
So next is similar way in decimal to octal and decimal to hexadecimal, similar procedure, but instead of that, you have to multiply by its base. So here I am converting from decimal to octal. So you get 153.513. So this is a decimal number. You have to convert it to a octal number. So 153 takes separately, divide by 8, and you get the reminder. So from bottom to top you have to write. So you write it as 231. And fractional part, you have 513, that is 0.513 you take and multiply it by base 8. So you get 4.104. So underline the 4, that is you are going to take 4 value, but in the next step you take it as 0.104 into 8 and multiply, you get the value as 0.832. Similarly, 0.832 into 8 you get 6.65. Next step, 0.656 into 8 will give you 5.248, and in the next step 0.248 into 8 will give you 1.984. So here you see that it is keep on going. You have not obtained any zero. So you can obtain at least on 4 to 5 digits, and you can put dot dot dot. So what is the converted octal value now? So 231.406517, and in the right hand side I have put a dot 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 because it goes on like this. So this is a converted octal number. Similarly, for decimal to hexadecimal, the same procedure, but the base value you have to use 16. So 2824, I am dividing it by 16. You get 11, 0 and 8. So for hexadecimal, you should not write 11 as it is. For 11, what is the equivalent hexadecimal value? B. So you have to write it as B, 0, 8, and I have a 0.5 is the fractional part. So I am multiplying by 16. So I get it as 8.0. So only you get 8 here. So B08.8 is the hexadecimal value. So in order to convert from decimal to any other number system, you have to find separately for integer as well as the fractional part. That is, you have to divide the with its base for integer, and for fractional part you have to multiply by its base. If you want to convert any number system to decimal, so you have to multiply each digit place with its base. Is it clear? So next we are going to convert other number system, that is binary to octal. So before going to binary to octal, so I am going to tell you how to convert, that is how to represent any digit in a binary value. So for example, if you are going to represent only two digit 0 and 1 means, so you need only one bit, because so you need to only represent 2 power 1 will be equal to 2. So you need, in order to represent two digits, you need only require one bit. That is, 0 can be represented as 0 and 1 can be represented as 1. So and in the next, if you want to represent four digits, that is 0, 1, 2 and 3. So if you want to represent four digit means how many bit you are going to require means, so when will you get 4? So 2 power 2 will get you 4 digits. So in order to obtain 4, you require 2 bits to represent this. So for example, so 0 is represented by 0, 0, 1 is represented by 0, 1, 2 is represented by 1, 0 and 3 is represented by 1, 1. So you required 2 bits to represent 4 digits. Similarly, if you want to represent 8 digits, so you can represent only in terms of 2 power terms. So for example, you are going to represent 0, 1, 2, 3, 4, 5, 6 and 7. So totally you have to represent 8 digits. So how many bit you have to require to represent 8 digits? Tell me.
3. 4, ma'am. 3,
4,
ma'am.
3. So 2 power 3 will give you 8. So to represent 8 digit, you require 3 bits. So how using 3 bits, how can you represent 0 to 7? So that I will explain. So for a so if you want to represent 0, 1, 2, 3, 4, 5, 6 and then 7 using a binary digits. So how will you represent? So how will you represent means, So that is, so I already said, so least bit will be 2 power 0 and the next bit will be 2 power 1, 2 power 2, so on like this. So you required 3 bits for representing 7 digits. So 2 power 0 will be 1, 2 power 1 will be 2 and 2 power 2 will be 4. So these are the 3 bits you are going to use. So that is 2 power 0, 2 power 1 and 2 power 2. So in order to represent 0, so this should be 0. So 0, 0, 0 represents 0. So and next is 1. So if you want to get 1, you should put 0, 0 and in the 1th place you get 1. Correct? So next is you want to get 2. So 2 means 0, 1, 0. So next is 3. So 3 means 0 and 2 plus, if you add 2 and 1 you get 3. So you have to put 1, 1 here. And next is 4. So 4 means you have to put 1 here, 0, 0 here. So 1, 0, 0. And next is 5. 5, how will you represent? 4 plus 1 will be 5. So, so 1, 0, 1. And 6. 4 plus 2 will be 6. So 1, 1, 0. And 7, how will you represent? 4 plus 2 plus 1. So 4 plus 2 is 6. 6 plus 1 is 7. So 1, 1, 1. So So, in order to represent 8 bits, that is 8 digits 0 to 7, you require 3 bits. So, first place will be 2 power 0, that is 1, and second place will be 2 power 1, that is 2, and third place will be 2 power 3, 4. So, you get 0 means represented by binary 0, 0, 0. 1 means you represented by 0, 0, 1. So, 2 digit is represented by 0, 1, 0. 3 is 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. So throughout the 5 units, you're going to use only this. So that is, you have to write from 0, 0. If you're going to use 3 bits means, you're going to use 0, 0, 0 to 1, 1, 1. So you have to write only in this order, that is from 0 to 7. So actually you are, it is, if you are practiced, then automatically you will be writing 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 100 101 110 111. You no need to write it 421 and then you have to find all these things. So by practice, automatically you will be writing all these things. So you have to write only in this order. And I have noticed some of the students will be mug upping in and writing in first column 0 0 0 0 1 1 1, next column 0 0 1 1. They will write in this order. So it is very bad habit. So write in this order only. So 0 means 0 0 0. 1 means 0 0 1. Then next 0 1 0. Next 0 1 1. So you have to write in the row wise. I have noticed lot of people have mug up and write in the column wise order. That is very bad practice, and you will make mistake also. So you have to write in this order only. So for example, if you are going to represent 16 digits, that is from 0 to 15. So how many bits you will use?
4 bits.
4 bits. So 4 bits is required to represent 0 to 15. So for 4 bit means next position will be, this is 2 power 0, 2 power 1, 2 power 2, and next position will be 2 power 3. So 2 power 3 will be 8. So 2 power 3 will be 8, and the 8th digit you will represent as, so in this you will be, so I will take a next page. So till now we have studied, that is we have written 0 0 0 to 0 1 1. All the things will be 0 here in the 8th bit. So next 8 will be 1 0 0 0 and 9 will be 1
1001.
1 0 0
Zero
1
zero
because 8 plus 1, and next 10 will be
1010, ma'am.
1 0 1 0.
10.
Then 11 will be, so you can see this. So 11 will be 8 plus 2 10 and 2 plus 1 11. So you will get 1 0 1 1, and then 12 will be 1 1 0 0, that is 8 plus 4 will be 12. Then 13 will be 1 1 0 1. So 8 plus 4 12, 12 plus 1 13. Then 14 will be 1 1 1 0. So 8 plus 4 12, 12 plus 2 14. Then 15 will be 1 1 1 1. So is it clear? So if you use 4 bit, you can represent 16 numbers. Similarly, if you want to represent 2 power 5, so you can write 32 bits, 32 digits. So on, you can keep on like this. So you can write for each digit equivalent binary value. So using this only, you're going to convert binary to octal value. So for example, you take 1 0 1 1 0 0 0 1 1 what 1 1 0 0 1. So for example, you take this binary value, you're going to convert it to a octal value. So octal, what is the base of octal? 8.
8.
8. So how many bit is required to represent 8 digits? How many bit is
3
required?
bits.
Huh?
3.
3. 3 bit is required to represent 8 bits. So you have to divide
Three.
this 3. That is you
Three
have
bit.
3 bits, right? So you have to divide this binary to 3 bits. So how will you divide means, so you have to take this binary point. So from the binary point you have to go in this direction and you have to go in this direction. So usually you will be going in this direction only, that is 2 power minus 1 minus 2 minus 3 and then 2 power 0 1 2 3. So from this point you have to, fractional part is you have to divide first 3 and then next 3. So you have no third digit here, you can put 0 here. Then here in this integer part you have to divide in this direction. So 110 is one group, 001 is one group, and 101 is one group. Suppose you have another one here, so you have only one left means no problem, you can put 3 zeros and you can combine this. So now you have to write the code. So what is 110? What is the digit for 110? 3 digit means மேல 421 போட்டு
6,
பாருங்க.
ma'am.
6. So this
6,
6.
ma'am.
What is 010? 421 மேல போட்டு பாருங்க. உங்களுக்கு வந்து
Three, ma'am.
2, ma'am.
Three.
421 மேல
2,
போட்டு
ma'am.
பார்த்தீங்கன்னா என்ன வரும்? 2.
2, ma'am.
சரியா?
2.
சோ அதாவது உங்களுக்கு பிராக்டிஸ் ஆகுற வரைக்கும் அந்த மேல அந்த டிஜிட்டை போட்டு பாருங்க. எந்த டிஜிட்ல இருக்கோ அதெல்லாம் எந்த டிஜிட்ல 1 இருக்கோ அதெல்லாம் ஆட் பண்ணிக்கோங்க. So what is 011? What
3.
is
3, ma'am.
3.
3.
And 100,
4, ma'am.
4.
4. And
4.
101,
5.
5.
5.
5, ma'am.
5. And then 001 is 1.
1.
So your octal value is 15436 point, sorry, 2 point. So point is 3. 3, you have to keep that point, and 6 2. So this is the octal value. Is it clear? So given is binary value. So you have to convert from binary to this binary to octal. So since octal you have 8 digits, for 8 digits you require 3 bits. So you have to divide each binary to 3 bits. So then how will you divide 3 bits? For just like that you cannot divide from the first to last. So you have to take the binary point. You have from the binary point right side you have to go, and left side you have to go. So from the binary point right side you have to group 3 bits. 110 is one group, 010 is another group, and then this side 011 is one group. So you have to divide this into 3 bit, and you have to write the equivalent digits. So 010 is 2, 110 is 6, 011 is 3, 100 is 4, then 101 is 5, and 001 is 1. So this is the equivalent octal value. Is it clear?
Yes, ma'am.
If anybody is having any doubt, you don't wait for the last minute. So at that time, if you have any doubt, at that time you raise that is you unmute yourself and you can ask your doubt. So next is similar way you're going to convert binary to hexadecimal value. So how will you convert binary to hexadecimal? So same value, any binary value you take. So for example, you take this is a binary value, and you are now going to convert it to a hexadecimal value. So hexadecimal, what is the base? 16. That is, you are going to have 16 digits. So how many bits you have to need to represent 16 digits?
4 bits.
4. So now you are going to divide the binary bits to 4 groups. So here you have to go in this direction, and left side you have to go in this direction. So divide the group. 1011 is one group. 10 you don't have this, so you put 2 zeros. This is another group. Then 11110, this is one group. 101 you don't have number here, so this is another group. So now tell me what is the value of 1000. Now in the top you put
11.
8421. 8421.
11.
11. 1000 is only you have 1 in the 8th position. So what is the value now? 1000 will
8.
be 8.
8.
உங்களுக்கு அதாவது இது பிராக்டிஸ்ல வந்துரும். இப்போ உங்களுக்கு கன்ஃபியூஸ் ஆச்சுன்னா அந்த டிஜிட்க்கு மேல 8421 போட்டு பார்த்துக்கோங்க. So what is 1011?
11.
8421 போட்டீங்கன்னா 8 plus 2 10, 10 plus 1 11. So what is the hexadecimal for 11? Hexadecimal digit for 11. Hexadecimal க்கு 11 க்கு என்ன? 11 அப்படியே எழுதக்கூடாது. What?
B, ma'am.
B. So then 0111, what is the value?
7.
7.
7,
And
ma'am.
0101, what is the value?
5.
5.
So now your hexadecimal value for this will be 57 dot, what is that value? B8. B8. This is the hexadecimal value. Is it clear? So binary digit you're going to divide by 4 bits, then that is you're writing the equivalent digit for that, you get a hexadecimal value. For octal conversion, binary to octal conversion, so you're going to divide into 3 because octal base is 8. So 3 bits is required to required 8 digits. So you divide into 3 and write the equivalent digit, you get the octal value. So this is the conversion from binary to octal and binary to hexadecimal. So far we have seen decimal to the other number system conversion and other number system to decimal conversion. Similarly, binary to octal and binary to hexadecimal. So then how will you convert octal to binary and hexadecimal to octal, hexadecimal to binary means that is very, very simple. That is, so for example, you have octal number 5368. So this is, sorry, octal number you don't have 8. So 5363. So this is an octal number. You are going to convert it to binary. So how will you write means this is very, very simple. So for each digit, you are going to write the equivalent binary code. That's it. So what is the, so for octal means you have to use 3 digit. So how will you represent 5 in binary?
101.
101. And how will you represent 3?
011.
011. And how will you represent 6?
110.
110. And how will you represent 3? 1
0.
1
011.
0 1 1. So this is the equivalent binary value. So if you have any dot here also, you can, so 2 will be 010. So this is the equivalent binary value. So similarly, if you have hexadecimal value, so similarly, hexadecimal value to binary, you have to write the equivalent binary code. So for this, you have to you require 4 digits. So B, how will you write? What is the code?
1011.
1011.
1011. So because B is 11, so 8 plus 2 is 10, 10 plus 1 is 11. So how will you write 3?
0011.
0
011.
0011. And what is the value of 6?
0110.
0110. Then you have a point. And what is the value of A?
1010.
1010. So that is your binary value. So from octal to binary, you have to write the equivalent binary code for that. So for octal means you use 3 bits and for hexadecimal means you use 4 bits. Then other hexadecimal to octal and octal to hexadecimal means in between you use binary conversion. That is very, very simple. So if you want to convert hexadecimal to octal means, so first you convert hexadecimal to binary. So hexadecimal இருந்து binary convert பண்ணுங்க, binary இருந்து octal convert பண்ணுங்க. So now if you have to convert octal to hexadecimal means, so you convert octal to binary, then you convert binary to hexadecimal. So that is hexadecimal இருந்து binary எழுதிக்கோங்க, அதாவது 4 bit யூஸ் பண்ணி binary எழுதிக்கோங்க. Then பைனரியில 3 3 டிவைட் பண்ணி அதுக்கு ஈக்குவலண்ட் ஆக்டல் எழுதினீங்கன்னா you will be getting hexadecimal to octal. Similarly, octal to hexadecimal conversion means, so first write the octal number. For that you write the 3 bit equivalent binary code and then you divide into 4. You write the equivalent hexadecimal value. So now you will get the octal to hexadecimal conversion. So this is all about the number conversions, number system conversion. So you have 4 number system, decimal number system, binary number system, hexadecimal and octal number system. So from one number system to another number system you can convert, and you have seen decimal to other number system conversion, other number system to decimal conversions, then binary to octal and hexadecimal, and octal and hexadecimal to binary, and similarly octal to hexadecimal and hexadecimal to octal. Is it clear, everyone, today's class?
Yes, ma'am.